Let's go ahead and practice making inferences when we take a look at the graph of a particular function together. So we have a twice differentiable function f as shown below. The domain is from -9 to +9, not inclusive of those ends. So that just lets us know where we are looking at on this function. We're told that we have 3 points of inflection, one located at x equals -3, x equals 0, and x equals +3. Let's focus on what inferences we can make about the function, its first derivative and second derivative, specifically when x is equal to 4. That's this location right over here. All right, let's go ahead and see what the questions we have are. The first one, it says, is based on the graph when x is equal to 4, the graph of f, or the function, has, and what we would say here is that it has a relative maximum. And when you look at our graph here, we can see that we have a relative max. It's not the absolute max. You can also see over here we have another max maybe happening at x is equal to -2, right? So this is just going to be a relative maximum located when x is equal to 4. All right, so let's just go ahead and say here that we have a relative maximum at this location. Now for this next blank, we're going to say whether there is an inflection point or not an inflection point. Now, inflection points are going to occur when the concavity changes. So look at this location at x equals 4. If you take a look at this function, it looks like this is going to be concave down. And so particularly when you look at this part of the function here, I'm just going to show here that from the left and the right side of that 4 here, we can see that this function is concave down, and so that there's no change of concavity. And so we would say that there's going to be no inflection point here. Notice where the inflection points are located on this function. Again, we had 3 of them with these green little circles here. This is going to be concave up, then this is concave down. So this is why we have a point of inflection where x is equal to -3. Then we have this concave down changing to concave up. We have another point of inflection when x is equal to 0. And we have another point of inflection at x equals +3 because it's concave up. Then it transfers to being concave down, specifically at x equals +3. But in this particular case, when we're looking at x is equal to 4, there's no inflection point because it's just concave down at this location. All right, for this next question, what do we see? It says, we can infer that f prime, or the derivative, the first derivative, when x is equal to 4 is blank and has blank. Now they're basically just asking us what is the derivative going to be at x equals to 4. So if we were to take the derivative, we would look at what the slope would be. And so if we were looking at this graph here, the slope at x equals 4 would be 0 because it would be tangent at this location to be a horizontal line. Now it could be going from negative to positive or positive to negative, but let's see what's happening here as you get closer and closer to 4. Here you can see the derivative would be positive. It would be positive, but it's becoming less and less positive as we get closer to this x value of 4. Once you hit the x value of 4, it's going to be 0. And then when you go past 4, what's f prime of x here? F prime of x would be more and more negative as you get to the right side of 4. So we know that f prime of x, or the slope of the tangent line at this location, would be 0. And it would be transitioning from being positive to negative. And again, you can see we have positive, positive, positive. Eventually it's 0. And then it's going to become negative as you go past x equals 4. Now for this next part, we're going to say there's going to be no relative extreme. We're only going to have a relative extreme if the concavity changes at this location. So that would be more talking about inflection points. So notice the concavity stays concave down around x is equal to 4. So we don't have to worry about any relative extreme in this particular case. If we had an inflection point, that would be a different story. And finally, there is one more question. It says, what do we know about f double prime, or the second derivative, when x is equal to 4? We can definitely say that it is going to be negative just because we can look at the concavity here, right? It is always going to be negative if it is concave down. If we were looking at a different case, like when x is equal to +1, like if you look at this location here, this would be concave up. So we would know that the second derivative would be positive here. If you were to look at when x is -2, you would see that this is concave down. Then the second derivative would be negative here as well, just like in this particular case where x is 4. But then again, differently, if you would look at another location where maybe x is equal to -4, you can see here that we have this concave up. So we would have the second derivative be positive here. So the second derivative, you can determine whether it's positive or negative depending on the concavity. All right, so there you just have one quick example where we are given the graph of the original function and we're just figuring out some information based on a specific point.